Hello, and welcome to Biology Lesson 2.06, the polymers of lipids. You might have noticed this is page 7 in your note packet. I got my whiteout out, and because I forgot to give you guys a page, I had to do a little bit of doctoring here. So I whited out the lines and I whited out the carbohydrate. That molecule is glycogen, by the way, but I left the lipids. So what we're going to do now is on this page, we're going to do lipids, proteins, and nucleic acids. We talked about the fact in the last topic on lipids when we were doing the overview that if I took a little bit of if I took one of these guys, it would look like this, and it's called a phospholipid. Now we're going to wait. This is a portion of a cell membrane, and we're going to talk about the specifics of phospholipids and cell membranes on the chapter. We do a whole chapter on just cell membranes. We're going to be spending a large portion of the first part of the year just talking about cells and organelles and how cells operate. So what I really want to focus on today is this structure right here. These are called fatty acid chains. And this is only, we do have a couple of different kinds of monomers. So this is one of the more common ones, but these fatty acid chains are also something that we want to talk about. Lipids are primarily made up of carbon and hydrogen and carbon, hydrogen, and oxygen, as are carbs. I don't think I mentioned that in the carb video. I think I'll just let that go for now. So, and we can draw them like this. So if we have this jagged line, no, I want to do, hold tight. So we can represent a phospholipid like this. Well, it's a zigzag line. What does this mean? This means each of the times where I change directions, there's a carbon atom here. Carbon, 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 carbon. And coming off of these carbons are hydrogens and oxygens. And we just leave the hydrogens and oxygens off so that we don't have to draw. It doesn't get as complicated. It's a lot easier to see. Well, we have two different types of fatty acid chains. So this is type 1. And it's called saturated, or a saturated fat. And you might have heard about this before in on food shows when they're talking about health. And I'm going to draw two of them side by side. The other type that we have is called an unsaturated fat, or an unsaturated fatty acid. And it looks like this. And let's draw a second one. And I'm drawing it on at an angle on purpose. If you remember, we talked about carbon being able to form 4 bonds. So if I look at, I'm going to get my pointer out with my pen. If I look at this carbon, I've got a bond here, and I haven't drawn, but there'd be a hydrogen that comes off of here and a hydrogen that comes off of here. So in a saturated fat, every carbon is bonded to 4 atoms. These are called single bonds. In an unsaturated, if you look at this carbon and you look at this carbon, so this is called a double bond. called a double bond. And that means that this carbon is only bonded to three other atoms. And this one would have, because it would have a hydrogen coming off. And this would have a hydrogen coming off. That's a carbon, and it's a carbon. And this changes the way the molecule behaves. So an unsaturated fatty acid, some of the carbon have double bonds. Well, if you look at a saturated, it's nice and straight, and it's a little bit like a yardstick that you would buy at Lowe's, or like we use in our classroom. If you look over by my whiteboards, I've got nice, neat stacks of yardsticks. These unsaturated fatty acids bend. You see how they're like, it's got a little bit of a bend to it? And they're like sticks you would pick up in your backyard. They're not perfectly straight. If you've ever tried to carry a stack of sticks from the backyard, you know, you kind of have to wrap your hands around it because they don't want to go together nice and neat. Well, this ability to stack really changes the way that they behave. So what we see, so some examples, let's go to some application here. Let's do some examples. And we'll do some examples here. So some examples of saturated fat is butter or lard or, oh gosh, I'll come back to that. Some examples of unsaturated are sunflower oil, corn oil, vegetable oil. So take a second. What's the difference? Give me some differences between these two. Well, if you said, let's do some characteristics. One, these are solid. Let's do some characteristics. And these are liquid. Well, why is that? A saturated fat can stack together super tight. Think about those meter sticks stacked on top of each other. That makes it, that gives them the ability to be a solid. But these guys are bent, they're not stacking, and so they're kind of they're hodgepodge. They're a little bit, they're sticking out everywhere, so that makes this a liquid. Did you also notice butter and lard are usually from animals? Or butter and lard are from animals. This comes from milk. These are all from plants. So that's why we talk about good fats and bad fats. Well, why is this a bad fat? What makes this better? It's liquid. Why is a solid so much worse? Because it's not only solid at room temperature, it tends to form solid clumps in your arteries, and that's not good for you. So we talk about this clogging your arteries. But unsaturated fats don't, in a sense, clog arteries. They can make deposits. So saturated fats can make deposits in your arteries. That's not good. Why? All because of this one little difference in that double bond. It makes them, you know, wonky. You can't put them together evenly, but these guys you can. And again, we're talking about these chains that are on the phospholipids, the fatty acid chains. So what are our takeaways today? So for lipid polymers, we talked about the monomer being a phospholipid, but we wanted to talk about these fatty acid chains in a little bit more detail. We have two types. We have saturated and unsaturated. Saturated don't have double bonds, and so they stack together really well. And we find them in animal substances like butter and lard. They tend to be solid, and they're not as good for us from a health standpoint. Unsaturated fatty acids, on the other hand, have these double bonds. They don't stack. They have to kind of stick out, and that makes them liquids. They're mostly from plants, and they're more healthy for us because they don't clog our arteries. We'll touch on this in a chapter or two. So that's what we're going to discuss about lipid polymers today. Thanks for watching and have a good day.